factoring. Okay, so we talked about factoring numbers and talked about factoring from terms. And so to do a quick review, let's look at 5n squared minus 30n. What can we factor out of this? Well, if we look at these two terms, we have 5n squared and we have negative 30n, right? Coefficients of 5, negative 30. This is a quadratic, two terms. A lot we could say about this. Now, I can pull a 5 out of each of these because 30 is 6 times 5. So if I pull a 5 out, I know that I would be pulling that 5 out and then I would be left with a 6 here. I also notice that I can pull one n out of each of these. So I can pull a 5 and an n out, leaving just an n here and leaving a negative 6 there. All right, then we talked about how if we set that equal to 0, right, then what we could do is we could say, hey, we know that if 5 times n is 0, or if n minus 6 is 0, this whole thing goes to 0. So if n is equal to 0, the whole thing goes to 0, or if n is equal to positive 6. So 5 times 0 times negative 6 is 0. 5 times 6 is 30. 6 minus 6 is 0. 30 times 0 is 0. All right, now what we're going to look at is we're going to go a step deeper, okay? So the first thing I want to do is go ahead and multiply out x plus 3 and x plus 4, okay? We're going to multiply that out. So if you remember, I'm distributing this whole thing here to the x. And I'm distributing that whole thing to the 4. Okay, if I do that, then I have x plus 3 times x, then x plus 3 times 4, plus x plus 3 times 4. Now I can distribute again. This x I can distribute in, and this 4 I can distribute in. So if I do that, x times x is x squared. X times 3 is positive 3x. 4 times x is positive 4x. 4 times 3 is positive 12. Then I can combine like terms. I have like terms here and here. Remember, like terms are the same variable with the same exponent. Both of them have an exponent of 1. 4 plus 3 is 7. So I have x squared plus 7x plus 12. All right, and I started with x plus 3 and x plus 4. Okay. Now, I can actually go the other way. I can start with x squared plus 7x plus 12. And just like I can take a number like, let's say 14, and I can break it into 2 primes, right? Or take any number, you can break it into whatever number of primes, in this case 2. Oh, excuse me. Ugh. And if I multiply those together, I get that. So in much the same way, when I multiply these two together, I get x squared plus 7x plus 12. So if I were to factor this, just like I do my 14 here, this would break into x plus 3 times x plus 4. And if I multiply those two together, then I get this number, x squared plus 7x plus 12, or more accurately, that expression. So what's important is that we recognize that we're actually factoring this the same way that we're factoring regular numbers. But since we have x's in there, we're going to factor these. There's going to be a way in which we can factor these. Okay. So let's say that we started with x squared plus 7x plus 12. How do I know what two things multiply together to give me that? Well, I want you to notice a couple of things. If I go ahead and set this up as a plus b times c plus d, and I multiply all of this out, okay? So if I multiply this times c, sorry, and then times d. So, in fact, let me do this on a new sheet of paper. So let's start with generically a plus b times c plus d. All right. Give me just a second here. All right. So here, if I go ahead and multiply this expression here times c and that expression there times d, I get a plus b times c plus a plus b times d. Then, if I factor in these, just like we had before, c time, we have ac plus bc plus ad plus bd. Okay. All right. Give me just a second here. All right, sorry about that. Okay. So we can see a couple of things here. Um, for example, and in fact, this is gonna we'll probably let me do this again. Sorry. We want to do this with x's. So x plus a and then x plus b. I think that'll show it better. So if we take this and multiply it by x and multiply it by b, we're going to have x plus a times x plus a times b. Then we'll factor in that, or we'll distribute in the x's. We'll have x squared plus ax. Then here we'll distribute this in. We'll have x times b plus a times b. Okay. Now, as we saw before, we have like terms. We have this and this are like terms because they have the same x's. Now, I realize I'm using a and b, but because these have the common factor of x, I'm going to pull x out here. So we have x squared plus a plus b times x, that'll be that, plus a times b. Okay, this right here is going to reveal to us how we actually factor these equations. So let me bring up our problem that we were looking at. That was x squared plus 7x plus 12. Okay. Now, if we look here, this is the same thing as this. So we see x squared here and here. We see x here, and then we see this here. So what we're looking for an a and a b, an a times b, such that it equals 12. Okay. And then we're looking for an a plus b, such that it equals 7. Okay. And sometimes you'll hear people say two things that multiply to give me 12 or the last term. And the same two things, the same a and b, if I add them together, they're going to give me the middle term, or 7. Okay. Now, in our case, if we look at 12, and we already know it's 3 and 4, but if we didn't, we could look at 12 and say, okay, that's 6 and 2. 6 is 2 and 3. So we have 2 times 3 times 2. And those are the prime factors of 12. So I can either do 6 times 2 or I could do 4 times 3. Well, 6 times 2 is 12, but 6 plus 2 is not 7. It's 8. I could do 12 and 1. 12 times 1 is 12, but 12 plus 1, that's 13. That's not going to work. But I do have a 4 and a 3. 4 times 3 is 12, and lo and behold, 4 plus 3 is 7. And so here, we essentially have 4 plus 3, x plus 4 times 3. And that's the same thing as our initial. This is 7, this is 12. So if we look, that was the product of originally x plus a times x plus b. So now I'm just filling it with fours and threes. X plus 4 times x plus 3. All right. So for your notes, what you'll want to kind of keep in mind is that when I have an x plus an a times an x plus a b, where a and b are numbers, right? You're going to end up with x squared plus a plus b x plus a times b. All right, so let's apply this to an example. Let me pull up an example here that we can look at. So we're going to look at x squared plus 10x plus 21. Okay. X squared plus 10x plus 21. So I'm looking for two numbers that are going to add to give me 10, and the same two numbers that are going to multiply to give me 21. All right, so if we look at 21, we know that's 7 and 3. Well, 7 times 3 gives me 21. 7 plus 3 gives me 10. So we found it. We found our a and b. So this would be x plus my a, which you could choose to be 7 or 3. I'll say 7. And then here, x plus 3. And then we could check it. How do I know that this is legitimately factored into this? Well, I could multiply it. So here we have x plus 7 times x plus x plus 7 times 3. I'll go ahead and factor in the x. This is x squared plus 7x plus 3x plus 21. Combine my two common factors, x squared plus 10x plus 21. And we're back to what we originally started. Good, so we know that this is the correct answer. Right. So remember again, this is kind of what we know, x plus a, x plus b. When those are multiplied together, they give us x squared plus a plus b times x plus a times b. All right, so let's work out a few more. All right, let's do x squared minus 9x plus 14. All right. Well, 14 can be 1 and 14. It can also be 2 and 7. And 2 times 7 gives me 14, but 2 plus 7 gives me positive 9, not negative 9. But what I also know is negative 2 times negative 7 gives me a positive 14. And negative 2 plus negative 7 plus a negative is a negative. So negative 2 minus 7, that's negative 9. And so the two numbers then are negative 2 and negative 7. So we'll have x plus negative 2 and x plus negative 7. Plus a negative is just minus. So we have x minus 2 times x minus 7. Look at another one. We're going to have a squared plus 2a minus 3. All right. So now I don't have x's, but I know what I'm doing. I need two numbers that when I multiply them together, they give me negative 3. The same two numbers, when I add them together, have to give me a positive 2. So, so I know if I do a positive 3 times a negative 1, that gives me negative 3. And a negative 1 plus a positive 3 gives me a positive 2. So negative 1 and 3 are my two numbers. So I have x minus 1 and x plus 3. I'm sorry, those are a's. So used to writing a's. I'll write that again. A minus 1 and a plus 3. All right. Okay. Okay. All right. Let's do x squared minus 3x minus 54. Okay. So remember, this is going to be of the form a plus b times x plus a times b. So in this case, if I add a and b together, it gives me a -3. And if I multiply them together, it gives me a -54. All right, so what I'm going to do is I'm going to do a factor tree of 54. 54 I know is 9 times 6. This is 3, 3. This is 3, 2. Okay. So I can have 3 and then 9, 18, 3 and 18. I can have 9 and 6. I can have 2 and 18 or 27. Is that right? 3 times 3 is 9 times 3 is 27. I think I said 18 earlier. I'm sorry. 27 and 2, 6 and 9, 3 and no, that's right. 3 and 18, 2 and 27, 6 and 9. Those are, and then of course, 1 and 54. But 6 and 9, I think, are the ones, there's a difference between them of 3. So I think that's going to be our closest. Okay, so how can I do the 9 and 6 to give me -3 when I add -54 when I multiply? So what I'm going to do is if I do a -9 plus 6, that'll give me -3. Because -6 plus 9 is going to give me a +3. -9 plus -6 is going to give me a -15. And I want just a -3. Okay. Then -9 times +6, that gives me a -54. All right, so my numbers are -9 and +6. So when I factor this, I'm going to have x minus 9 times x plus 6. And that is factored. All right. Now let's go ahead and multiply that out to see if we, in fact, are correct. So I'm going to take this and multiply it, distribute it over that addition. So we have x minus 9 times x plus x minus 9 times 6. X here, going to multiply over, subtraction. This is x squared minus 9x. Then here, 6x, so plus 6x, and 6 times -9, -54. I can combine my like terms here. And x squared minus 9 +6 gives me a -3 minus 54. All right, and we're right back to where we started. So that is the correct factoring. Correct factoring is x minus 9 times x plus 6. X minus 9 times x plus 6. All right. Let's do another one. Let's do x squared plus 8x plus 7. So once again, when we have something in this form, we know that there's going to be two numbers that add together to give me 8. And the same two numbers are going to multiply together to give me 7. So what could they be? Well, if we look at 7, there's only two things that multiply to give you 7. That's 1 and 7. Now, it also so happens that if I add those two, I get 8. So it looks like I found it. 1 times 7 is equal to 7. and 1 plus 7 is equal to 8. So that means this is going to be x plus 1 and x plus 7. All right, go ahead and do another one on this sheet. Let's do v squared plus 5v minus 6. All right, two numbers that add to give me 5. I could set it up like this if I want. Same two numbers have to multiply to give me negative 6. All right. Well, I know that 2 and 3 give me 5. 2 times 3 gives me 6. But I want negative 6 and I want positive 5. Is there a way to do that? So 2 times negative 3 gives me negative 6. Negative 2 times positive 3 gives me negative 6. But if I add these two together, 2 and negative 3, that gives me negative 1. If I add negative 2 and 3, that's going to give me positive 1. Neither one are going to give me 5. So what else multiplies to give me negative 6? Well, negative 1 and positive 6, or positive 1 and negative 6. Both of those also multiply to give me negative 6. Negative 1 plus 6 equals 5. That's going to be my guy. Because positive 1 plus negative 6 would be negative 5. So we're going to have negative 1 plus positive 6. It's going to give me 5. And negative 1 times positive 6 gives me negative 6. So this is going to be v minus 1 times v plus 6. Right. We are cruising. Let's do another one. All right, let's do m squared plus m minus 12. M squared plus m minus 12. So again, we're looking for, if we looked at this in terms of x, right, we always write it like this. There's two numbers that I add together to give me the middle term, and those same two numbers I multiply together to give me the third term, okay? So what two numbers do I need to add together that gives me the coefficient in front of this? It's not seen. That is a number 1, not a 0. If there was a 0 here, then you would have m squared minus 12. But we don't. We have m squared plus m. So there's an implied number 1 there. But when I multiply those same two numbers, there is a negative 12. All right. So if I look at negative 12, that could be a negative 6 and 2, negative 3 and 2, 2. It looks like 3, 2, 2 here at the bottom. Any one of those could be negative. All three of them could be negative, but we're only looking for two numbers. Well, negative 6 plus 2 does not give me 1. Oh, look at this. 4 and 3. Positive 4, negative 3. I add that together, I get 1. So I bet you that's it. Positive 4, negative 3. I add those two together, I get 1. And positive 4 times negative 3 gives me negative 12. So this is going to be m plus 4 times m minus 3. Okay. Let's do another one on this sheet. Let's do n squared minus 11n plus 24. Okay. All right. So we want two numbers that add together for my middle term or middle coefficient, which is negative 11. So two numbers, an A and a B. Sometimes I do an underline, sometimes I do A and B. I kind of change back and forth just to show you there's more than one way to look at this. Okay, so A plus B gives me my middle term coefficient of negative 11. That same A and B, if I multiply them together, give me a positive 24. Okay. So 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. All right. So I've got 4, 4 and 6. And 4 and 6, I really can't combine to get 11. I can do 2, 4, let's see, 4 times 2 is 8. 8 and, 8 and 3. Okay, I can add 8 and 3 and get 11. I can multiply 8 and 3 and get 24. So I think I'm close. So how do I add them to get negative 11, but multiply them to get positive 24? Oh, if I do negative 8 plus negative 3, that would give me negative 11. Because if I add 3, just positive 3 to negative 8, it's going to negative 5. And if I add positive 8 to negative 3, that's positive 5. But if I add negative 3 and negative 8 together, that's going to go down to negative 11. And if I multiply negative 8 and negative 3, that gives a positive 24. So this ends up being n minus 8 times n minus 3. So this is called factoring. I'm taking a quadratic and I'm factoring it down into two binomials, a trinomial to two binomials multiplied together. All right. All right. So now what I want to do is the same thing we were doing earlier, and that is we're going to set this equal to 0. All right. Set this equal to 0. All right. So first thing we're going to do is n squared minus 9n plus 8 is equal to 0. What does n need to be? So in order to find this, we're going to have to factor, right? Because you don't know intuitively what just to stick in for n that would make this work. So we're going to factor. So remember, when we have something squared, obviously we're dealing with the letter n here, and I'm always going to show this in terms of x. But we have two numbers that we're going to add together. That's going to give me the coefficient here of negative 9. And those same two numbers are going to multiply together to give me this last term of 8. Okay. So I want two numbers that I add together that equal negative 9. And those same two numbers, I multiply them and they give me positive 8. Well, what two things multiply to give me 8, add to give me negative 9? Well, 2 and 4 are not going to get us to a 9, but 1 and 8 can give us to a 9. So I know 1 and 8 And I know that -1 times -8 gives me +8, but I'm going to need them both to be negative so that when I add them together, it gives me that -9. So now I've factored this. This is n minus 1 times n minus 8. And if that's equal to 0, then n can either be +1 or +8. In either case, if I plug in a 1 here, it makes this 0. So 0 times 1 minus 8, which would be -7. 0 times -7 is 0. If I plug in 8, 8 minus 1 is 7. 7 times 8 minus 8 is 0. 7 times 0 is 0. So if I put in a +1 or a +8, that will solve. Now, be very careful because a lot of students will get confused and notice here how we have a -1 and a -8, but here we have a 1 and an 8. So you kind of have to keep everything straight and know what you're doing, or else you're going to land on the wrong number. So make sure you keep your ideas straight here. All right, so let's do another one like this, except I'm going to add a step of algebra. So I'm going to do m squared is equal to 8m minus 12. Okay. All right. So in order to get this into the proper form, notice that it's not in the proper form. I need it to be variable squared plus something times the variable plus the last number equal to 0. So what I'm going to do is I'm going to move the 8 to the side. If I move the m squared over here, then I end up with a -m squared, which we can do, okay? We can come here and we can subtract m squared from both sides, and we can have 0 is equal to -m squared plus 8m minus 12. But then I've got this -1 in front here. So then what I need to do is multiply both sides by -1. -1 times 0 is 0. -1 times -m squared is +m squared. -1 times 8m is -8m. And -1 times -12 is +12. Now, it's actually easier if I start with this, my original problem. If I just subtract 8m from both sides, and then add 12 to both sides. So both end up with the same scenario. We have m squared minus 8m plus 12. Okay, so we started with m squared is equal to 8m minus 12, and we ended with m squared minus 8m plus 12 is equal to 0. And now I'm looking for two numbers that multiply to give me 12 that add to give me -8. So that looks like a 6 and 2, right? I could do a -6 and a -2 because those multiply to give me +12, but they'll add to give me -8. So we've got m minus 6 and m minus 2. All right, so what would I have to plug into m for this thing to go to 0? It's not -6 and -2. Be careful for that. I would have to plug in a +2 here to make this factor go to 0, and then the whole thing goes to 0, or I'd have to put in a positive 6 here to make this factor go to 0, this quantity, making the whole thing go to 0. All right. Let's do another one like that. We've got b squared minus 12 is equal to negative b. Okay, so I can see that I have b squared on this side and another term on this side, and then my third one over here. So I'm going to add b to both sides. Okay, and this is going to be b squared minus 12 plus b is equal to 0. Now I need to make sure that I'm in the right order. Now I can't just move around subtraction, so I'll change this to addition by making that b squared plus negative 12 plus b. So now I can say b squared plus b plus negative 12 is equal to 0. Plus a negative is just minus. So b squared plus b minus 12 is equal to 0. So two things that are going to multiply to give me negative 12, but add to give me 1. They're going to add to give me a positive 1, and they're going to multiply together to give me a negative 12. And it doesn't matter if I do it like this or if I show it like this, right? It's the same thing. Okay, so 12 can be 4 and 3. I think those are a difference of 1, so I think I'm onto something there. So if I have a positive 4 and a negative 3, that would give me a positive 1. And it would also give me, if I multiply them, a negative 12. So I'll have b plus 4 times b minus 3. And that is equal to 0. So now, what does b need to be in order to force this equation to 0? Well, if b was either negative 4 here would make that factor go to 0, or in this case, if b was 3, it would make the whole thing go to 0. So negative 4, positive 3.